There are many issues in terms of access to clean and safe water in Nepal. So with recent census data, more than 95% people have access to water supply. But if we talk about quality, there are only 16% who are having access to safely managed water supply, which is coming directly from the tap.
NWASH is a government-operated management information systems. So it is a national database for the collection of all water supply-related assets like intakes, reservoirs, taps, and various other assets.
Once the data are put in, it is a geo-reference system where the data are geo-referenced. The data is collected through the mobile applications, and then later on in dashboard you can see the analysis. One of the components in NWASH MIS is NWASH inventory, where we collect the data of the assets, about the assets age, about the assets conditions, and what the assets serviceability, what kind of service the assets delivers. It later on translates into what kind of investment will be required based on those data sets, how we should improve those assets based on the data sets that we achieve.
The information that we are getting in the NWASH portal and the picture that we are receiving are not fully matching, or there is some contradiction on the information and pictures that we have there.
There are like a lot of INGOs and NGOs supporting the data collection, which is a good thing, but that is creating a challenge for us, as the enumerators are coming from different backgrounds and different technical expertise. The standardization of the enumerators is becoming challenging. And to overcome that, the validation process needs to be robust in order to ensure the data is in good quality.
Dr. Rajit came up with that idea. Maybe AI solution could be one which will help us to solve that issue that we are facing currently with NWASH, especially in terms of validating the data that we have in NWASH.
There are a wide range of faults which can occur to taps, reservoirs, and water resources. I would say that most important faults are: first, taps missing meters. This can be problematic because when this happens, the government can't charge for water uses, and collecting payments for water use is critical to have funding to maintain systems. Second, reservoir lacking capacity. This is an issue because if reservoirs are under capacity, then they don't have enough water to meet the needs of the community they serve. And third one is lack of hygiene around taps, reservoir, or water resources. Where hygiene is lacking, then water is not safe to use.
So we've been using AI, image recognition, for detection of wash infrastructure like this, tanks, taps, these kind of things. We have used thousands of images, photographs from NWASH, and use this image to build AI model to identify the objects, that is taps for instance, and the problems in those images, such as broken pipes and corrosions and these kind of things. We tag different objects in the photographs, thousands of them ideally, and once we have that, we feed these data sets, tag data sets to the model. We build models, so it's an iterative process. We build different models, so it's like we might have built thousands of models and once a model is built, we try and check the accuracy of the models with other data set.
So far in NWASH, there are almost more than 774,000 taps, photographs of these kind of things. So we are talking about in 1 million components in Nepal.
The AI is fairly accurate while calculating the volume of the tanks. There would be deviations from the actual value, 10 to 15% deviations on the calculations. And it is also subject to the quality of the photographs, the guidelines that we need to define. So these are the learnings that we have had. But yeah, I can say that fairly accurate with good photographs. We did a little experiment to identify the accuracy of the model. In this process, we collected some 200 samples of photographs, and then asked a human expert to identify the different objects within that data set. Similarly, we also asked the expert to identify the faults such as breakages and corrosions. And similarly, on the other side, we used our model, AI model that we had built to identify the same problems and same objects. What we identified was, in case of identifying the objects, the model was equally capable to what a human expert, WASH expert would do. In case of identifying problems, it was even better compared to the human expert.
So looking into the findings so far that we have received from this pilot work, it has given us some confidence that okay, AI is working, especially to identify the issues and some risky data. And it's also kind of convincing for us that that will reduce time that all the validation or people validating data are taking. So that is one kind of convincing thing that we are having with this pilot.
Overall, we are hopeful that there is a role of AI to play to improve the accuracy of the data in NWASH. More accurate data will enable more informed decision making around the repair and maintenance of WASH assets, and ultimately will enable more people in Nepal to have access to safely managed drinking water.